So we're going to be talking about the blockchain challenges, which is also known as the trilemma, because there are two basically. So what are the current challenges of the blockchain, and then how do we actually scale the blockchain? Because in order for the blockchain to become widely adopted, widely accepted as what it teaches to be, it has to actually be able to adopt multiple users, give people the promise that they actually expect it to give them basically. So on a personal note, I'd like to say this before I begin proper, that while the blockchain is revolutionary and obviously as we have been told and as we are saying, has the potential to change our lives and our society, we must also admit that it is not necessarily the solution to everything basically. So because now there's this phase where everybody wants to squeeze blockchain into everything, and everything has to be on the blockchain, and this simply cannot hold. And this is why we have to come to a time where we know what should be on the blockchain, what can the blockchain help us with, and then how can we scale it in that regard basically. It was just like the machine learning craze when it first came out, and every startup wanted to have machine learning in their and every startup wanted to have machine learning in in the applications. Use something like blockchain to basically everybody wants to apply blockchain right now, but blockchain really should not be applied everywhere. Now the blockchain has lots of flaws at the moment, but it's an ever-growing space with lots of talks, counter talks, and opinions. No one size fits all. There are people that I'd like to call the active blockchain guys. Basically, they are like the extreme left guys, and why we must know that nothing is certain. We are all just being optimistic and trying to solve every bottleneck that the blockchain is bringing. And we're also hoping that this piece of technology will also reach its potential. Hence, I'm going to put it here. It might look funny to you, but hence, like religion, it's up to you to believe in the blockchain technology. Because if you go on different forums, you are going to see talks. I've been on forums and I see people talking about the why blockchain will not work, the bad part of blockchain, and for a moment I was actually convinced the blockchain is going to fail. There was a time I was actually convinced the blockchain might fail. Yeah. So like religion, it's up to you to actually hold on to what you believe. If you think the blockchain can fail, you have to look into it, see what's happening, see what can be scaled, see what can be done, ask the questions that needs to be asked. That's basically how people are. So yeah, I'd like to know if I am clear enough, because I'm actually, oh boy, because I'm actually trying to speak as loud as I can right now.
Yeah, you're good.
Okay, that means I have to shout basically. Okay, so like I was saying, the blockchain has lots of flaws at the moment, and it is up to you to actually believe in the potential of this technology, because there are people that I like to call the anti-blockchain guys that are actually going to give you reasons. I think it's your mic, not your volume. So what do we do? What do we do? Okay, can you guys just give me a minute? Let me just switch stuff with my mic, sorry. Maya, can you please give me, I was trying to get feedback. Can you please give me feedback if you can hear me properly now? Okay, I think I should be clearer now. Okay, I think I should be clearer now, basically. Okay, so let's move on. So what I was trying to say before I get into the blockchain trilemma properly. So what I was trying to say before I get into the blockchain trilemma talk properly is that we have to acknowledge that yes, there are some flaws that actually exist in the blockchain space right now, but we have to also acknowledge the insane amount of work that people are actually doing to fix these things, because the blockchain is pretty much still a heavy space, and basically people are working to fix these flaws and make it deliver on the promise that we are selling to people basically. And I'm going to say again, it is up to you to actually believe in this blockchain technology, and let's be optimistic and see what it brings. So the trilemma, what are the trilemma basically? There are three things. There's decentralization, there's security, and then there's scalability. Now, what does this trilemma basically mean? It means that in any effective blockchain system, it cannot have all these three complete. That is, it cannot be decentralized, it cannot be secure, and it cannot be scalable at the same time. These things are mutually exclusive. You can at most have two of these things and not have one. Now, if we want something, oh boy. Uh, can you guys see on it, please? Because I'm actually getting feedback. I can't. Okay, all right, then I'll just continue. Sorry. So these three things are basically mutually exclusive, and you cannot have them all together complete in the blockchain system. Now, this blockchain timer was actually put forward by the man himself, Vitalik Buterin, the sort of founder of Ethereum, and it states that blockchains by design can only be scalable and secure but not decentralized, secure and decentralized but not scalable, scalable and decentralized but not secure. Now, in our utopia of blockchain, we want all three things to actually be present, because we are obviously aiming for perfection here. If when you're coming to the blockchain space, most of the things that are done here is actually transacting value. It's actually transacting value basically. So you want to make sure that you are hitting all points. You want to make sure that it is scalable. You want to obviously make sure that it is secure, and you want to make sure that it is decentralized, which is one of the core messages that we're spreading to people now. The fact that the blockchain aids decentralization, and people want decentralization. People want the power to be in their hands. People want their data to be in their hands. So this is the blockchain trilemma. This is what we are going to be looking at today. We're going to be looking at what exactly they are in details and how we're actually working to fix these things basically. So before we go into these things proper and how they're actually being fixed, let's talk a bit about consensus mechanisms, because like you see me right there, ensuring trust in a trustless system. So consensus mechanism is actually pretty much important to the blockchain, because it helps with decentralization and security basically. So this is how we secure the blockchain. This is how we make sure that the blockchain is secure and decentralized. This is how we make sure that it is not only one person that is making the decision of the data that is stored and taken off the blockchain basically. Now, layer one protocols have no central authority by between transactions and states. Yet, networks must actually reach a consensus or an agreement on its correct state in a secure manner. Now, a consensus algorithm is a mechanism through which all the participants of a blockchain reach a joint agreement about the ledger state. Basically, when we have something like the blockchain, where the data is actually, present in everybody's hands, sort of, when you want to enter a piece of data into this database that is replicated across multiple nodes, all of us have to independently verify that this data should be entered. So if, let's say, the blockchain is a small database that is only replicated among 10 nodes, at least 5.1%, or let me just say six of those nodes has to actually say yes, this data is valid and should be entered into the blockchain before this data is actually entered into the blockchain. Now, how do we actually reach this? Now, if we were actually together in a small room and we have 10 people, we could actually say, all right, what's your choice? Should it be entered? Yes, yes. The stuff about let the yes raise their hand and the yes, stuff like that. But in this case, we have nodes spread all across the world. We have nodes in China, we have nodes in probably Bangladesh, we have nodes in the US, we have nodes in Mexico, probably Nigeria. So we are spread all across the world, and yet we must actually reach a consensus without actually being together. This is what the consensus mechanism does, and that is how decentralization and security is enforced basically. Now there are a lot of consensus algorithms. We have the most common one, which is what Nakamoto actually came forward with, is the proof of work, which is what Bitcoin and also Ethereum at the moment uses. Now, we have proof of work, we have proof of stake, we have delegated proof of stake, and then we have proof of space and time. And actually, we have about 10, 15 more that I probably haven't heard of, because mathematicians and economists are basically always working, like I said, they're always working to make sure that we develop a system that is trustless and yet we can trust, basically. So if a system is trustless, we must still ensure trust, which is actually kind of seems like a paradox here, because this system is trustless, but yet we have to ensure that our trust is basically, and this is what this consensus algorithms do. So we are going to be looking at two of these consensus algorithms, two of the most popular basically, and this is the proof of work and then proof of stake. Now, consensus algorithm, like I already talked about what it does basically and how it is used in reaching what should be entered into the blockchain. Now, in terms of proof of work, this method, all the available miners compete with each other in a complex mathematical puzzle, which is difficult to solve but easy to validate. Now, I'm going to show us a diagram. I'm going to show us a diagram shortly that is going to actually explain this stuff better, basically. So validating blocks is actually quite expensive. Now, if you've been on Twitter quite well, like I said, there is always a lot of bad news when it comes to blockchain and decentralization and stuff like that. Yeah. And what you people might see most times, what you people might see most times is the Web 2 versus Web 3 war. What people might see most times is the Web 2 versus Web 3 war. But what is also even more prominent in the blockchain space is actually the inter-tribe war in the blockchain space. That is this blockchain versus that blockchain, this consensus algorithm versus that consensus algorithm, and this person coming out to say that this consensus algorithm cannot scale and is not secure enough and should be dumped and stuff like that. Yeah. So we've actually seen a lot of people come out to actually attack the proof of work consensus, in terms of saying that it is actually expensive to maintain and carry out, and the fact that it's actually the most evidence is the fact that it consumes a lot of electricity, like a whole lot of electricity. I can't actually remember the statistics offhand, but it's actually pretty much enormous, the amount of electricity that is used in mining Bitcoin in proof of work consensus. So this is one of the things I must take note that validating a block is actually expensive. But the people actually doing this proof of work are actually incentivized with Bitcoin. So every time you perform a proof of work and your block is actually, you actually win this puzzle competition, you get rewarded with a couple of Bitcoins, basically. I'm sorry if you guys can't hear me properly. So this the computing power that the miner offers is used to hash the candidate blocks data. Now I'm going to show us a diagram now that's going to basically explain how proof of work works. It's going to be like a flow. Now, although the proof of work can be considered as one of the most secure, it's actually at the moment the most secure form of consensus algorithm, because of the fact that actually, it's evidence that because it uses this much energy and GPU and stuff like that, it's actually very, very secure. because before you can be able to attack a system that uses proof of work, you have to also perform an enormous amount of work that would actually, at the end of the day, negate the gains that you would actually get. So basically, if you decide to attack the system, you might end up doing so much work that you will spend much more than what you'll be gaining. And basically, no one wants to actually do that. Now, so this is the flow for the proof of work, and what the miner takes is the marker root of the transaction, the timestamp, the previous block hash, the version, and then a none. Now, it uses this data to create a block header. Now, what it does is it then hashes this block header. Now, there's already a target block hash that is set by the system. Now, once he hashes this block header, if the output is actually in bits. Now, if this block header output that is hash, if the output is less than the target block hash, that means he has won. So basically, what you are looking for is that you must produce a value that is less than the block hash target that is set by the system. So after all your hashes, you must come out with a value that is actually less than the block hash target. So as you can see the arrow, if yes, it is less and you are the first, you create a new block. If no, what it does do is this first four data, the first four data, they are constant. What you need to change is just change the nonce and then you rehash basically. So now this seems like a simple process, yes, but when you consider the fact that number one, there are probably thousands of miners also competing for this solution to get this solution right, and the fact that the numbers involved are actually enormously large. So there is a lot of probabilities that you won't get in the first 1,000 or million tries, and that's why you have to make use of machines that have high hash rate. And what be my high hash rate is the fact that you can go through this. I don't know if you guys can see my mouse. You can go through this cycle pretty much fast, so that if you are using a machine with high hash rate and you create an hash of your block header, if you don't get the value that wins, you can quickly go back and continue doing it fast, very fast enough. So if you are using a machine that is actually more powerful than my own machine, when I am producing, when I'm producing hash rate of about maybe 1,000 hashes in a minute, and you are producing a 100,000 hashes in a second, obviously you have more upper hand than I do. So that's basically how the proof of work consensus works.
Hello.
So, yeah.
Sorry to interrupt you. Are you using a headphone or earpiece?
Yes.
It's really affecting your audio, and then you're too fast. You're talking too fast.
Okay, which one am I? Should I just reduce the speed of my
Let's try using your normal computer's speaker and see if the audio will be clearer.
Okay, just give me a minute then.
Okay, thank you.
Yeah, I'm really sorry.
Okay, am I audible now?
Yes, it's better.
All right, then that's basically my okay. So I really hope you guys haven't been lost so far, but the comment sections are actually there for your questions. So please, if you have any questions, make sure you drop them there, and we're going to go through them after the presentation. Yes. So that's basically how the proof of work consensus algorithm works. Now, if we move on to the proof of stake consensus algorithm, in this consensus algorithm actually came in 2011 when a Bitcoin forum user proposed it, and basically how it works is that in order for you to actually be able to produce blocks and verify stocks, you have to stake a couple of, you have to actually have a stake in the system basically. So So an individual node in the network is randomly selected. This node will be responsible for verifying the next block. In order to become a validator, a node must first in order to be able to verify, a node must first stake. Okay, I think I'm going to start from, I'm really sorry, I think I'm going to just go back to proof of work so that for clarity's sake, because it seems that I just became clearer. My bad. So we were talking about the consensus algorithms basically. So we wanted to know more about the consensus algorithm before we know basically how to scale the blockchain. Yeah, okay, so if there are questions, just drop them in the chat and alert me, and then maybe you can start answering them. Maybe do a short break in between. So I'm going to so basically we're trying to understand the proof of work consensus before we go into how we're actually scaling the blockchain proper. So the proof of work consensus, like I said, is basically the most secure consensus that we have right now, but there have been a lot of criticism for the fact that it is actually very, very expensive. It uses a lot of energy at the moment, and people think that it is actually unmaintainable at the long run. But right now, it is the most secure form of consensus algorithm that we have, and it is being used by Bitcoin and still being used by Ethereum, but Ethereum is actually hoping to move on. Okay, so what is the main difference between mechanism and algorithm of basically they are the same thing. There's no difference. Mechanism and algorithm is actually the same thing. It's actually how something works. So there's I'm sorry if my use of language has actually been confusing you rather, but there's actually no difference. It's mechanism and algorithm is basically how something works. Yeah. So there's the consensus. When you see me say consensus algorithm, it basically means mechanism. Now, what is have a stake in the system mean? Okay, define POS without using the word stake. Okay, sorry about it. Yeah, when I get back to POS, I'm going to do better. So proof of work, how proof of work works is basically every node try and generate they try to compete and solve some mathematical puzzle, which is actually very difficult to solve. Now I'm going to show us the diagram that actually explains everything that goes on with proof of work. Basically, I think diagrams are actually easier to understand in this concept. Now, when a miner wants to use proof of, and in a system that uses proof of work, when a miner wants to actually verify a block, what it does is it takes this 5 piece of data, the Maku root. Now, the Maku root basically contains the hash of all the transactions in the block is trying to verify. I'm sorry if I was too fast. The Maku root contains an hash of all the transactions in the block that the miner is trying to verify. I hope that we know what an hash basically means, or hashing functions basically. So it basically takes an input and then it gives us a sort of malformed output that you can actually recognize. That's just what it does. So Maku roots, it takes the Maku root, it takes the timestamp, which is the time the block is being formed. It takes the previous block hash, and then it takes the version and then the nonce. Now, once it takes this piece of data, it collates them together to create a block header. Now, it then takes this block header and hashes this block header with the SHA-256 algorithm. Now, the output of this SHA-256 algorithm is then compared with a certain block hash target. Now, this block hash target is already set by the system. For every block, the block hash target is actually changed. Yeah. So once you have the block hash target and you have the hash of your block header, you compare it. If what you got, if the output of your puzzle is lower than the block hash target that was set by the system, that means that you have won. But if it exceeds it, if it's higher, that means that you have to begin the whole process again if someone hasn't found it, because you are not the only miner. There are thousands of miners actually vying for this thing. So everybody is trying to produce an hash that is lower than the block hash target, and the first person to produce this hash wins, basically. Now, this hash and the block hash target is actually a very enormous number, basically. So that means you might have to compute for 1,000 of times before you actually get the value, and that is why you have to have a high performing machine. Basically, you have to have high GPU and stuff like that, and that is why proof of work is actually very expensive. So I'm going to just answer this one. Nonce in terms of mining is just a random number that you actually use to just in mining, it's actually just to spice up your puzzle solving stuffs, basically. So let's say the first time that you tried to solve this number, you picked 25 as your nonce. Now, if you solve the puzzle and the output of a puzzle is actually greater than the block hash target, as you can see here, if it is greater than the block hash target, that means you have a no. So you adjust your nonce. What you just do is you just increase your nonce, basically. So if your last nonce was 25, then the next nonce you just pick 26. This is just to deviate, to make sure that you get a different output this time. It is just basically a guessing game. There's no set way to actually get this thing. You are just guessing a number, adding it, hashing it, increasing the number if it does not work, hashing it, and then comparing again. That is what you're doing, and that is what a nonce does in this context, basically. So that is basically how proof of work works, which is maybe you can say that's tautology, but that's how it works. Basically, you take you compute to solve a puzzle, and then you compare it to the block hash target, and then if it is lesser than the block hash target, that means you win and you get a couple of Bitcoin, and then you start vying for another block. That is how proof of work algorithm works. And like I said, there has been a lot of debate over this algorithm, despite being the most secure that we have at the moment. There are talks that it is all maintainable, and the fact that it uses an enormous amount of electricity, it might in the long run, you might all have to dump it, because now people want to go green. So the next popular consensus that we have is the proof of stake consensus, which was proposed in 2011. So proof of stake, so basically, like proof of stake, someone said I should explain proof of stake without actually using stake. Now, so I'm just going to basically use an illustration. Now, if you want to why there is stake in this context is because if you want to volunteer to guide something, why should we trust you to actually act in the best favor of that thing? Yeah, so if we have a pool of 1,000 naira notes and we ask you to guide it, why should we trust you that you won't just take this naira notes to yourself, or actually connive with a couple of guys to come steal these naira notes? Now, one way we could do this is to make sure that you have a stake in this. I'm sorry for using the word stake again, but one way to ensure is to basically make sure that you have something to preserve, basically. So looking after this pool of naira notes is basically looking after your own naira notes, because your own naira note is also in there. So you don't want it stolen, because you don't want your naira note stolen, basically. So basically, for proof of stake, you want to make sure that you are vested in the system, and that you have a stake in the system, an enormous stake at that in the system. And so that's just how proof of stake works. And I'm going to show us another diagram that's actually going to make us understand better. But basically, instead of miners, for proof of work we have miners. In proof of stake we have validators. And like the grammar here says that a loan must actually first mortgage a certain number of tokens as stake or property. You can think of this deposit just like a bank deposit. The number determines the probability of you being selected as the next validator in the next election. So what are the pros? I'm going to show us the diagram and explain better, but I just want to tell us the pros and cons of this particular consensus. It is energy efficient, unlike proof of work where you expend enormous amount of energy. In case of proof of stake, you actually don't need much energy. It is just a couple of people who have a stake in the system, and they can say, yes, this data should be added because I have a stake in the system and I don't want it to owned, basically. And you don't need any special equipment, like I said. You don't need any hash rate, power or GPU or electricity to start with. Now, what are the cons? They are not proven in terms of security. Validators with large holdings can have big influence, and some POS require the lockup of tokens for a minimum amount of time. Now, these are actually very valid takes against the proof of stake algorithm, because that's why we have a lot of consensus. Actually, people believe that proof of work, which is the most secure at this point, is actually too expensive to maintain. And people believe that the second most popular consensus, which is the proof of stake consensus, is actually not secure enough, which I actually kind of agree with, because now you are selecting a couple of people to just become validators. It is not really decentralized, if you ask me. And this is something that even Vitalik has come under fire for, because people believe that Ethereum moving to proof of stake is actually not going to be as secure as it is. And right now, security is a major issue when it comes to the blockchain. There's a lot of things to be said about security. There's a lot of apps going on, and then people believe that moving to proof of stake again might not actually help the security issues right now. So if we look at this POS flow, the proof of stake flow, the guy that is vying to become a validator just takes these 3 data, creates a block header, hashes the block header. Now, if you guys can see my mouse, basically, this coin age of A is greater than block hash is. Now, if I go back to this, it seems there is another difference in terminology. In POS, miners no longer exist. Instead, there is a verifier, and this algorithm does not allow everyone to mine but create blocks. The selection of validators is not a completely random process. Now, but once you have stake, like let's say we have 100 validators in the system, how is the next validator to actually verify a block? How is the validator picked? Now, this coin age greater than block hash target is what is the random situation that actually picks the next block verifier. So what this means is that once a validator has hashed his data, we make sure that the coin age of A. Now, there's actually a lot of random ways to hash that different proof of stake consensus platforms use. In this case, the coin age of A actually means how long A has staked his token. Yeah, so it means that for how long have you been a validator? For how long have you staked? Have you had a stake in this system? So they believe that if you have been here long enough, then that means that you actually believe in the system, and that means that you actually be willing to protect the system. So this is actually kind of thinking that goes here. There is another one that is actually called a random block selector, which actually takes the person with the lowest stake and the highest time that they have been. So like I said, there is a lot of random process that goes into picking the next verifier when it comes to proof of stake algorithm. And so basically, once your coin age is greater than the block hash target, then they pick you as the next verifier. If not, you have to wait it out to the next round. In the next round, your coin age must have increased, and then they will check if you will see if you will be picked again, basically. Now, we've now talked about the 2 most popular consensus algorithm, and the issues with them, and how how people are actually trying to solve these issues. Because like I said, there's a lot of backlashes of these founders about why they shouldn't pick this consensus algorithm. Most of the wars that we see online most times is Web 2 versus Web 3. But like I said, there's an intertribe war of Web 3 versus Web 3 about this blockchain, saying that they have a more secure algorithm than this blockchain, and why people saying that Binance Smart Chain is not actually secure because it uses some proof of stake that is not secure enough and stuff like that. So how do this thing actually then help in scaling the blockchain? What are the scaling solutions that are being proposed, that are being looked at right now, and how is the blockchain being scaled at the moment? Now, scalability is basically a very important talk when we come to blockchain, because we are people are counting blockchain to to become the de facto choice for handling transactions worldwide. You understand? Like, we are hoping that it replaces stuff like Visa, like PayPal, and stuff like that. But at the moment, these stores like Visa, and they handle thousands of transactions per second. And when we look at blockchains like Bitcoin and Ethereum at the moment, Ethereum blockchain on its own handles at most 15 transactions per second, which we should all agree it's very, very slow. If every other payment system went off and we had to rely on the blockchain, on the Bitcoin blockchain right now for payments, we would basically be screwed. Because imagine having to process just 15 transactions per second. There's going to be stampede of transactions basically, and it's going to be untenable. So this is why we have to find a way to actually scale these blockchain solutions. And when we go back to the trilemma, we see that now Bitcoin and Ethereum are both secure and decentralized, but they are not scalable. And of course, that means that if we go back to what we said about them being mutually exclusive, we see that yes, you can be decentralized and you can be secure, but then if you have those two, you cannot be easily scaled. Now, this is the workaround that people are trying to find, and there are a lot of smart people working on this, and we are going to be looking at the solutions that they are basically coming up with. Now, achieving scalability while maintaining security and decentralization in the system there's no easy solution. Many solutions have been proposed and implemented. Now, there are two types of solutions that have been proposed and maintained. There's the layer 1 solution, and then there's the layer 2. Now, what we mean by layer 1 solutions? Basically, layer 1 platforms are these popular blockchains that we know that are on their own. Example, we have the Bitcoin blockchain and then the Ethereum blockchain, basically. Those are layer 1 platforms. And when we talk about layer 1 solutions, we mean that actually scaling those platforms themselves, actually scaling Ethereum itself, not looking for side chains to help it, not looking for, not basically a separate network that is just aimed to support layer 1. So layer 1 is going to be there because they are the guys that we already know and trust, and then layer 2 is just going to come in and support this layer 1 solutions. Now, when we talk about layer 1 solutions, basically we are going to be looking at two different solutions on layer 1, and that is the consensus algorithm improvement and sharding. Okay, I think I'll just quickly take this question because I've probably been talking long enough. When comparing your value on the block hash target, is there a range that is being considered, or as long as your value is less than? Yeah, there's no range. Basically, that's the crazy thing. I know it's kind of like crazy. There's no range. Once it's less, you won. There's no range. As long as if the block hash target was 5 and you get 4.9, you won. It's 4, you won. But if you get 5.0, you basically have lost because it's not less at that point. If you get 5.1, you've lost. So there's no range. Once it's less, it's less. So I'm just going to continue now. Layer 1 consensus algorithm improvement and then sharding. Like I said, we have been talking about consensus algorithm, yeah, and we talked about how people are actually now moving from proof of work consensus algorithm to proof of stake because people feel that proof of work is on the long run is not maintainable, takes too much electricity. You don't want to, carbon dioxide stuffs and ozone layer penetrating and stuff like that. All these stuff that goes with grain, going grain and stuff. So people are trying to move away from consensus algorithm. Now, apart from that, actually, because it takes ton of work to actually compute these puzzles. Like I said, before you actually win a puzzle, you might actually have done a million transactions. Basically, it takes quite a number of time before each block is actually verified and added. And the number of time that a block is added is basically how fast a platform is. So if it takes in Ethereum, basically I think every 15 seconds or so is when blocks are added. And so basically that means that if you have another platform or another blockchain that adds block every 2 seconds, something like Polygon does. I think Polygon adds blocks every 2-3 seconds. That would basically make it faster. You understand? But because if you are using proof of work, there is no way you are going to be adding a block in 2-3 seconds, because 2-3 seconds you've probably not found the solution to your puzzle. You understand? So that's why people are considering moving from proof of work to something else like proof of stake, delegated proof of stake. There's actually this one that I actually loved one time like this. It's called proof of space and time. And if you guys know BitTorrent, there's this guy that founded BitTorrent, founded another blockchain, called it Share. I wanted to use this proof of space and time complexity. Now, the proof of space is just basically you are going to be delegating space on your laptop instead of machine. You don't need a high performance machine. What you just need is space. What you just need is hard drive to do, and then they store a couple of mathematical expressions. We're not going to be going deep into all this stuff basically, but just know that there are a lot of algorithms out there that are aiming to make sure that the blockchain is scalable. So layer one solutions, like I said, there's consensus algorithm. So a good example is transition from proof of work to proof of stake algorithm. Example, I think in the next 3 months we might be seeing massive transition from Ethereum. They are basically now moving, because the Bitcoin chain is now live, so they're basically now moving to X 2.0, which basically is going to be using proof of stake. We are seeing a lot of platforms also coming up that they are purely using proof of stake consensus algorithm from the start. You understand? Like I've said earlier. So we are now gradually moving from proof of work to proof of stake. Now, there's another one called sharding. Now, if you are familiar with database stuff here, you know what sharding is. So sharding is basically just increasing the amount of it's basically just increasing your database. Yeah. So this meant it just breaks your database into smaller pieces and hands these pieces over to different nodes. So instead of one node storing the whole database, in their memory, they are only responsible for storing a shard. And Ethereum is also going to be making use of these sharding stuffs. And I think they are going to be having, for a start, they are going to be having 64 shards, basically. So you can't just breaking your database, breaking the Ethereum database. When I say database, please don't confuse it as your MySQL stuff. We are talking about decentralized stuff here, but in the broader sense, it's still a database, basically. So breaking up this database into smaller, smaller pieces and adding it over to the nodes, so that the nodes don't actually have to have the whole database in their memory, which takes a lot of space and time and power to do, basically. Now, each node is not maintaining a copy of the entire blockchain, like I said, but they just hold its own assigned shard. Example of the protocols that are currently, exhibiting this sharding is Tezos. You might have heard of Tezos. They're just basically now coming up really well. And there's Zilliqa, and then there's Qtop, basically. So that's basically for layer one solution. So like I said, layer one solution is actually just improving layer one itself. And as you can see here, when we take the Ethereum blockchain as an example, when we take Ethereum blockchain as an example, Ethereum is now migrating in order to scale. Ethereum is now migrating from proof of work to proof of stake, and then they are going to be implementing sharding. Now that is layer one solution. That is layer one scaling. Now layer two scaling, basically, there's a lot of examples of layer two solutions, but I just picked two to talk about here. And those are channels. Some of the most popular. We have channels, and then we have rollups. Now, what are channels basically? Now, channels basically they make use of smart contracts to compute transactions off chain. Now, here's the thing. Imagine that we are basically saying the Bitcoin is going to become, the number one transaction ledger in the whole world. That means every little thing that you buy is going to go on the blockchain. Imagine I want to go and get coffee. I'm going to the bar to get a couple of drinks, and for every drink that I get and I pay, it's actually recorded on the blockchain. Now that's too much. People are busy processing millions of dollars in transactions on the blockchain, and I'm using my own $2 for beer to actually take up space, and it might seem insignificant to you, but in the long run, a lot of people paying for beer is actually taking up much space that should be used for bigger transactions basically. So the whole point is, I hope I was clear. The whole point is basically to make sure that some transactions that might be considered less less should I say valuable are actually completed off chain, and then they are, after the whole process is done, they are stored on chain. I'm going to explain better, please. So in the case of me going to the bar, what channels we do is, once I get to the bar and I tell the barman that I am here to drink to stupor tonight, what the barman does is opens a channel smart contract for me, and I'm going to put in, say, so I decided to come and do Dorime at the bar, and I come with 250,000 naira. So I put my 250,000 naira in this payment channel, and this is how much I'm going to drink. Now, of course, if I don't end up drinking like that, on a normal day, there's no smart contract. If I give the bar 250K, I should give my change later, I might think it's going to reap me or stuff like that. But what we do is we put my fund in the smart contract. Now, we should know about smart contracts. Really, it's actually, you don't have to trust anybody, just trust the contract. So I'm very certain that my fund is going nowhere. So what I do is I put the 250K in the smart contract, and then I start ordering drinks basically. So for every drink I order, instead of them to record it on the blockchain, what I just do is I just sign for each drink off chain. I sign a message that says, okay, I took one whiskey basically, and it's 50K, and so I'm going to give in exchange for the whiskey that the barman is giving me, I'm going to give him a piece of signature, more like a check, that I can then submit to the smart contracts, and then the smart contract will then later on release that amount to him. But he can submit this check or this signature anytime, but he won't submit it yet, because that's the point. Basically, we do not want to bother the blockchain yet. We want to make sure that we finish all our transactions, and I am basically done with my drinking before we then put the whole stuff on the blockchain. So what we do is I keep taking drinks, and for every drink that I take, I give him a signed check, give him a signed check. Now, at the end, if I end up spending 200K, and I'm like, all right, barman, I'm done. Like, I'm out. I can't take any more stuff, basically. What he then does is we then decide to close the channel. Now, when we decide to close the channel, what he does is he then takes the check. Now, one thing you must notice about channels is it is only the barman that can close it. I can't close it. Now, this poses no threat to me, because if the barman closes the channel, I get my funds back. So what the barman does is he takes the proofs that have been given him, the checks that have been given him, and submits it to the smart contract. The smart contract verifies that it is actually my signature, and checks how much drink that I have had that is on the signature that I gave to him, gives him the amount, and closes the channel. Once the channel is closed, he gives me my balance of whatever my balance is, and then he puts the transaction on the blockchain. So this is actually very smart, because instead of, after maybe I had 10 bottles, instead of 10 different transactions going on the blockchain, we have just one whole transaction going on the blockchain, and I'm basically having all the things that I bought in it. So that's basically what channels do. That's what state channels do. Now, what are they useful for? If we must say what they're useful for, lots of state updates, like I said. So 10 bottles of whiskey does not just go on the blockchain. I know there was a time that basically buying pizza was actually going on the blockchain, but with state channels, we don't want to do that anymore. We want to make sure that all these little updates are actually done off chain, and then the old stuff is then put on the blockchain. Now, so the actual when number of participants is known upfront, like I said, this stuff is just going to be between me and the barman, basically. So this can also be seen sort of as a limitation, because it does not accept open participation, basically. So if the barman open a state channel when I came in, if another drunkard like me comes in, he has to open another state channel for this guy. We can't use the same state channel. So you might see that as a sort of limitation, but who cares? It works. So there are two types of channels right now. There is a state channel, and then there is a payment channel. So the state channel is basically used for stuff like maybe like transaction that does not really involve money, while payment channels are actually used for stuff that solely deals with money. You understand? So that's the type of channels that we have. Now, for another type of layer 2 scaling that we have is ZK. Basically rollups actually. Now, rollups is actually a different topic on its own, and there are a lot of rollups. Now, just like state channel, basically the main goal of rollups is to make sure that we only post one transaction on the blockchain that represents everything that we have done. So in terms of ZK, it means that computation is done off chain. So imagine if we have we have a smart contract, we have a transaction that computes, that computes what can I say an example? Voting, basically election. Yeah. So instead of us computing these stuff on chain, we can compute them off chain and then just send the transaction. I'm going to actually explain this better, please. And now I have to actually warn you that ZK is a monster. Like, it's actually one deep mathematical stuff, and I'm only going to basically explain it on the surface. Now, if I explain it on the surface, you are going to get it. You are going to understand. The most important thing is that you understand what ZK is, what it does, how it helps the blockchain. You do not necessarily have to understand the math behind ZK. Well, if you are that curious, you can just, go study mathematics in your MBA, basically, or your master's. Yeah. So that's just ZK. We're going to talk about ZK basically. So zero knowledge rollups, what they do is the transfers happen off chain, and then they generate a cryptographic proof. This proof can come in form of snacks, which are called succinct non-interactive arguments of knowledge, or stacks. So there is snacks or stacks. Not only stack. So scalable, transparent arguments of knowledge, snacks and stacks, they are known as validity proof. Now, validity proof is the most important concept in ZK, because I'm going to try and explain ZK in a broader sense now. Let me first read this last line first. The ZK log smart contracts maintains the state of all transfers on layer 2, and this state can only be updated with a validity proof. Like I said, it's very important to have validity proof. This means that ZK rollups only need the validity proof instead of all transaction data. With ZK rollup, validating a block is quicker and cheaper because less data is included. If you ZK zero knowledge rollup, zero knowledge is actually different from zero knowledge rollups. Now, zero knowledge is actually a sort of math concept. Now, what it means is that imagine I can prove something to you without actually proving that thing to you. Now, it sounds kind of like weird, like I said. Imagine if I wanted to tell you that I know your name, and I'm going to actually prove, I'm going to make you believe that I know your name without actually telling you your name. You understand? So imagine I want to show you that that you put a lot of keys on the ground, different keys, like 1,000 keys, and you want me to pick the key that opens your room without actually picking it in your presence, without actually showing you that key. You understand? So you're just going to give me all the keys, tell me to pick the key, and I'm not actually going to pick the key and show you, but you're going to believe that, oh, I know the key. It's actually it sounds really weird, and I actually implore us to actually go research more on Z case, and we can go back on Discord and have a lot of discussion. I'm open for discussions on these stuffs about Z case and rollups and stuffs basically. So like I said, zero knowledge rollups. So now when we want to apply zero knowledge to blockchain, it becomes a sort of a bit different ball game, because now we are trying to say that once a couple of transactions take place, we are not posting all those transactions on layer 1 on Ethereum, but yet we are just going to be posting a proof on the layer 1, but yet we want layer 1 to actually believe us that those transactions are actually correct and there is no malicious transaction in that transaction. So this is actually going to help Ethereum scale up, because like I said, one of the main reasons why scalability is actually hard to actually, one of the things that actually makes scalability really hard to, implement is the fact that there is a limited amount of data for each block. There's a limited amount of memory for each block. So each block can only contain so much transactions. So it's not Ethereum's fault that it's only processing 15 transactions per second. It's because for each block, it cannot have, there's a limit. I think there's about, I can't really remember, but I think there's about is it 10 MB size for each block. So basically there's a limit to the block size of the platform, and hence there's only so much transaction that can happen that you can batch. Now, when it comes to zero knowledge, this is where zero knowledge helps to solve it. I'm sorry, I really hope that zero knowledge, I'm explaining it in a very clear way, because I know it can sound confusing, but please just keep an open mind and just let me explain it as I am doing, basically. So this is how zero knowledge helps in scaling Ethereum. Imagine instead of posting a lot of transactions, like 100, now Ethereum, let's say the Ethereum block cannot take 100 transactions. Normally, an Ethereum blocks cannot. Yeah. Now, when zero knowledge comes in, what zero knowledge is going to do is take 5,000 transactions, bundle it into a validity proof, and instead of sending the transactions to layer 1, it is sending a proof to layer 1. And layer 1 trusts the validity proof or zero knowledge to be correct. So in this case, we are trusting mathematics to be correct. I mean, we've always trust mathematics from cryptography to hashing and encryptions. We trust mathematics to it works. Once mathematics tells you that it works, basically. Yeah. So layer 1 is going to trust that the validity proof being sent by this zero knowledge is correct. Now, instead of sending a lot of transactions, what he's sending is just something, a proof. Now, a proof, when the transaction that made the proof is actually probably about 20 MB, the proof might just be like 15 kilobytes. You can see that there is actually a drastic change. And I mean, to be honest, I said 20 MB and 15 kilobytes, that's about 19 point something MB. It is massive. You might think about 19 MB as a little bit, but when it comes to actually scaling Bitcoin, every megabyte matters. Every size that we can actually squeeze together matters. And you're going to learn this more basically when you come across smart contracts and actually writing smart contracts here. So that, I hope, if there are any questions, if there's something that is not clear about this zero knowledge, just post it. I'll try to, if it is due to the fact I didn't explain well, then I will explain again. Now, if it is due to the fact that I actually didn't know it, then that means we both have a lot of research to do, basically. But if you have any question about zero knowledge, just post them in the chat and let's just have a chat about it. Now, the pros and cons of zero knowledge. Now, fast finality time, since the state is instantly verified once the proofs are sent to the main chain. Now, I think there's a question. Okay, thank you. Okay, yeah, that's nice. Okay, so the pros and cons, we are almost done, basically. If I've been taking too much of your time. Yeah, the pros and cons of zero knowledge is just the fact that the pro is the fact that there's faster finality. You understand? Like I said, if you have to verify something that is 20 MB large and something that is 50 kilobyte large, obviously you are going to do one faster than the other. So there's faster finality. You do stuff really, really fast. You verify stuff really, really fast. And then the con basically is the fact that some of these zero knowledge concepts, they are not EVM compatible. Now, what do we mean by EVM compatible is the fact that they don't play with Ethereum at the moment. So we are trying. So basically, for zero, if you are trying to write smart contracts that involve zero knowledge, you can't actually use something like Solidity or Viper. You have to use their own design language, which is at the moment we have Cairo, basically. So that is basically all for the blockchain trilemma. I really, really hope that you able to get confused about a lot of stuff, really, that you're able to ask questions more now, yeah, about stuff that about this, because the blockchain trilemma is actually a very, very important discussion. Every moment you go to something like Reddit or forums, you get talks about these stuff. So it's nice that you know about them and that you're able to actually ask specific questions about these stuff. this I'm going to play. I don't know if this slide is actually worth sharing, but I'm going to be sharing this resource for your further use. You can go on and just read up on these stuff and stuff like that. Ladies and gentlemen, thank you very much for coming to my TED Talk. I hope that it was worth your night, and I hope that we're able to learn a thing or two. Thank you very much. Thank you.
Thank you very much for that, Prometheus. I think you really done a good job this evening, and I think on the chat we've been responding to some questions that have been coming in, and I think so far so good. If you haven't responded to your question, you can actually just type it or tag me on the channel. But somebody just asked, is the size of a block constant, or can the size be increased one way or the other? That was the question.
Yeah. Okay. Yeah. So I don't know if my constant, but yes, there's actually a limit. There's a limit. There's a block limit, basically, in terms of size, where the block can actually go past that size. So I'm sorry that I can't actually give you the exact limit right now, but I'm sure it's not going to take more than a Google search for you. Just search Ethereum block limit. It's going to give it to you. Yeah. So now let's say, for hypothesis sake, it's 5 MB. Now you cannot go beyond that 5 MB. Now that 5 MB is actually constrained by code. So yes, if there's enough votes from the Ethereum developers community, if the EIP is raised, there's actually been, now, when I'm really sorry that I'm taking time, when concepts of actually scaling Ethereum came by, the first thing that we actually thought of was actually increasing the block limit, because obviously that's like the easiest thing to do. But due to some other factors, we can actually just increase so basically, long story short, we can't actually just increase it. We can do it with code, like we can change it in code, but in the long run, it is not actually good for the platform, basically. So it is just it has been decided that for now it is going to be left like that, even in the Bitcoin block limit. But for now, they are staying off it for now, because I think there is going to do more harm than good, because basically there has to be a limit to what you can do on the blockchain. We don't want while loops running. We don't want infinite stops. Basically, what you want to do on the blockchain has to be sourcing. Basically,
thank you.
I hope that answers your question, Billy. Like I said,
yes, thank you very much for. Yeah, thank you very much for that. Also, please, some resources have been dropped. If you want to understand the concept of ZK, zero knowledge, very, very well, you can check the resource channel. A material has been dropped there. And this is one thing you still need to understand when it comes to this ZK thing. See, it's like, Ethereum actually processed this thing for like, I think, is it 8 minutes every transaction? So now imagine the millions of persons in the world that are making use of Ethereum to transact. That's why you get high gas fees and the rest of them. But this particular protocol is just like some sort of, like, it describes something. When somebody's trying to prove to you that he or she knows your name without the person knowing your name. So one is actually doing this thing without validating, and the other is actually validating before. That's why we have optimistic rollup and the other ZK rollup. So a document has been dropped. Go there. It's really, really mind-blowing when you want to talk of this rollup, this StackNet, and in fact, another language is being used when you want to enter this L2 StackNet layer. That's Cairo language. So the material has been dropped. Do yourself some good to check it out. I think somebody was, Phil. In Bitcoin, there is a block limit. There is a maximum size of block can be. In Ethereum, there's a gas fee limit. There is a maximum gas. Okay. I think this is just speculating. Thank you very much for that. Please, any other question? I think we've answered most of the questions for this night. Yeah, I think we've done justice to that. So if you have any other question, okay, somebody saying a joke. Well, the thing is this thing is very easy. It's not the way you think it would be. Possibly the terms and the stuff you're hearing for the first time, but don't worry, fret not. Just go straight to the resource. That particular Ethereum material that was dropped can actually scale you through L2, basically. And Polygon, well, some persons belong to a school of thought that Polygon is like a side shard. Some said Polygon is a layer 2. Yes, Polygon is a layer 2, but there is more to it. So you can just pick that up and just do these things at your free time. So I think any other person. All right. Yes, the resource has been dropped. Okay, thank you. very much. Okay. One last question for the night. Since the ZK phenomenon isn't sending all the transaction, it has bundled. Where does it save them? If there's any reason to refer to some of the transaction bundle with ZK, how do you access them? Okay, this is let me just use normal layman to just explain this thing. I know you, right? Now, somebody sent me money to send to you. Normally, I'm supposed to send you that money every 8 minutes, but because of the fact that this network is congested and I don't have that gas fees to pay, now I will claim that I know you and I will give you the check or the money. Now, if there's any issue, then they'll have to revert back to me and I have to check my own diary that do I really know this person? Do you understand? That's why some of these things, if you bridge, because I know most of us are traders, if you bridge, some will tell you you wait for 7 days, while some will actually tell you you can actually bridge out very, very fast. So just do yourself some good and just check that material out. Everything is there. Everything is there. Thank you very much. I think if you want to say anything, Prometheus.
Yeah, well, nothing really. I hope, like I said, now I already said that this night you might not have all your questions answered. This discussion is just to like stir up the curiosity in you, get you really confused about some stuff. Because when you're confused about stuff and you start to ask questions, you start to understand stuff. And to be honest, if you want to become, an Ethereum developer or a blockchain developer, you have to understand the concepts, the basic concepts, like the foundations of these stuff, the scalability of the stuff, how are we scaling, what are the options and stuff like that. So I hope that this has triggered, some sort of curiosity in you, and they are now asking questions and hoping to find them. And basically, I might not be able to answer the questions well enough. Do well to research about them, watch YouTube videos and stuff like that, and bring them on Discord and let's argue. Thank you.
Okay, all right. Thank you very much. Thank you very much. Have a wonderful night rest.
Yeah, guys. Thank you for coming. Bye. Good night.